Hello students, welcome to Preliminary Chemistry and the energy topic. This is video number 6, fractional distillation. We've already looked at photosynthesis as the source of, or at least the process which converts light energy from the sun into chemical energy in a form that we can use. Now we can use that both as living organisms, but also through the fact that that energy can be tied up for long periods of time in compounds that have become fossilized, that we then extract and use as part of a group of fossil fuels. We mentioned those in a previous video too: coal, oil, and natural gas. And one of the things that's important about crude oil or petroleum is that it has a number of fractions within it. And what we need to do is we need to separate those fractions. And the separation method that we use is based on differences in the boiling points. So it's just a process that takes advantage of the fact that the different compounds in crude oil have different boiling points, which means that we can set up a column such as the one that's displayed on this video, on this slide, and you can see that the lighter, to change the color of that, the lighter carbon compounds, 1 to 4 carbons, have the lowest boiling temperatures, and so they will come out of the column first, right down to the ones that are very large, that are going to remain potentially as liquid or semi-solid sludgy residues at the base of this column, in these greater than 70 carbons in length. So these can be very long chain compounds, very important compounds in both aviation, of course, octane, carbon with 8 carbon compound is the petrol that we put into our cars, diesel oils, lubricants, such as these different types of oils, waxes and polishes, fuel oils for shipping, and so on. All of these are components of crude oil and can all be extracted by heating up the crude oil and then allowing those fractions to separate as we cool the mixture down in the column and draw out each of these different gases as they are condensing back into a liquid form. So this gives us a range of different types of products from crude oil, with the lighter fractions boiling off first, those with the lower boiling points, and the heavier fractions falling effectively to the bottom of the fractionating column. The crude mixture is usually heated up to about 370 degrees, and that pushes it beyond the boiling point of most of the components of the mixture, and all of those gases now will spread out to fill the container. They will rise up through the column, and as they rise they will cool and condense out to be collected at the varying levels. Now sometimes the proportion of heavy fractions can be proportionately high, and as a consequence of that we may sometimes need to crack them into smaller molecules. Now cracking can be a thermal process just through heating, or a catalytic process, so catalytic cracking, which can take large molecules and crack them into smaller molecules. And it's often these small molecules that are critically important to us, either as a fuel source or often as the precursor for polymers, plastics, and that sort of thing. Fractional distillation is just one of the separation methods that you would have looked at. You may remember from the first topic, the chemical earth, that we looked at. So it's not necessary for us to go into a lot more detail now, other than to be aware of the fact that there's lots of different hydrocarbons, compounds containing hydrogen and carbon with different numbers of carbons that we can extract from crude oil. And the way that we do that primarily is through the process of fractional distillation, based on differences in boiling point. And then for those longer chain compounds, we may find some more processing occurs as a result after this, after the oil has been distilled, to remove each of those component fractions. Thanks for watching.